Okay. Sorry, I think I got the wrong title. I just noticed that my title that was advertised was different, so I hope you don't have objection to this. But the fact that our political leaders, our governments, have not dealt with human-made climate change is going to make it the moral and political and legal issue of the 21st century. The situation now is that there continues to be a large gap between what is understood about global warming by the relevant scientific community and what is known about global warming by the people who need to know, and that's the public and our political leaders. The fact is, people don't see it. It's not easy to recognize, but the fact is that we have a crisis. We have an emergency. And the reason it's hard to see is because the climate system has a great deal of inertia. The ocean is 4 kilometers, 2.5 miles deep. The ice sheets are a couple of miles thick. They don't respond quickly as we apply forcings to them. But that inertia is not our friend, because once they do begin to respond, the momentum that they gain can cause the dynamics of the system to take over, and the situation can become out of our control. For example, if an ice sheet begins to disintegrate, you can't tie a rope around something that's more than a mile thick and the continent scale. The bad news is that it's become clear in just the last several years that the safe level of atmospheric CO2 for the long run is no more than 350 parts per million. And we've already increased it from 280 parts per million a couple of centuries ago in the pre-industrial atmosphere to 389 parts per million today. The good news is that if we would phase down the emissions rapidly, we could restore the atmosphere to less than 350 parts per million. And there would be other benefits of doing that. But we need to move quickly. Just to say a couple of words about climate tipping points. I mentioned ice sheet disintegration. What we're doing by adding greenhouse gases to the atmosphere is reducing the heat radiation to space so that there's a temporary imbalance. You've got more energy coming in from the sun than heat radiation going out, and that's causing the planet and the ocean in particular to get warmer. And as the ocean gets warmer, the ice shelves, which are the tongues of ice that come out from Antarctica and Greenland into the ocean, those ice shelves are melting. And as they disappear, the ice sheets, the large ice sheets behind, sitting on the continents, can begin to discharge large amounts of ice into the ocean much more rapidly. And as I say, there's a danger that this can become a dynamic situation which is then out of our control. And another tipping point is the survival of species on the planet. We know that we're putting pressure on different species in a number of different ways, but on the long run, the most important way is the shifting of climate zones, because a given species can only survive within a certain climate range. And as the zones shift, now a given average temperature line is moving poleward at a rate of about 50 to 60 kilometers, about 35 miles per decade. And as so far the total movement is not large enough to cause extinctions, but as that range, as that movement becomes larger and larger, it's going to put pressure on more and more species. And we know from the Earth's history that when there was global warming of 5 or 6 degrees Celsius, which has happened several times in the past, it caused the extinction of half or more of the species on the planet. And then over time, new species evolved, but that required hundreds of thousands of millions of years. So if we drive species to extinction now, it will leave a much more desolate planet for not only young people, but any generation that we can imagine. So we don't want to do that. This was my first grandchild. I took this photo in year 2000, 10 years ago. And I showed this at a scientific talk at Lamont Geophysical Observatory because the day before, the newspapers had called me the grandfather of global warming, and which is actually not true. There were scientists well before me that I talked about global warming, but I was really a grandfather, at that time my grandchildren were not affecting my thinking the way they do now. But at a few years, this is about 5 years later, this is when Sophie was 6 years old by this time, and she had a younger brother, Connor. And this was in 2004, and that was the year that I decided. So I testified to Congress in the 1980s, and this got a lot of attention, and then I testified in 1988, and then I testified once more because I thought what I said wasn't very clear in 1988, so I wanted to clarify that. But then I decided to get out of this public stuff altogether because I'm the opposite of Alec. I'm not a public speaker. I'm a scientist who likes to do science, and I'm taciturn and things. So I decided I'm getting out of this business, and I did. For 15 years, when I got requests for an interview on TV or something, I would refer to Steve Schneider or Michael Oppenheimer. These are really good scientists who are really articulate, and they like doing media. So I got out of the business for 15 years until 2004, when I decided this gap between what was understood by us scientists and what was known by the public was so large. And I thought, well, if I give one really clear talk, and I'll prepare this carefully and write it out, and I'll have the scientific papers to back it up. So I gave a talk, and this was one of the charts that I used in my talk, because I'm trying to explain how the greenhouse effect works. And, you know, the greenhouse gases now reduce the radiation to space by 3 watts per meter squared. But on the other hand, humans are also putting particles into the atmosphere. This is the visible air pollution that you can see. Aerosols, they're called. And those reflect sunlight. So that cools the Earth because it reduces the amount of sunlight absorbed. So we don't know exactly what the net effect is. And we had sort of estimated it might be about 2. I was getting Sophie to explain it's about 2 watts per meter squared, which is like having these little Christmas tree bulbs, 2 of them over every square meter on the entire Earth. But Connor could only count 1 watt. And it could be, in fact, our uncertainty is enough that it's someplace in that range. Now, if we're beginning to understand this better, and the basis of our understanding is in large part based on looking at the Earth's history, how the Earth responded in the past when there were changes in the boundary conditions, such as atmospheric composition or the surface properties. We also now have satellite observations of how the Earth is changing in response to these rapid increases in greenhouse gases in the last several decades. And we also have models which help us to interpret those observations. But nevertheless, you can ask the question, why should we be concerned about human-made climate change? Because we know that in the Earth's history there have been huge changes of the Earth's climate. And these questions can be asked by well-educated people. In fact, this is word for word, which was said on National Public Radio by my boss's boss's boss, the NASA administrator. So, and we can, however, answer these kind of questions. I think it is useful to look at long time periods when climate was very different. This is the temperature of the deep ocean over the last 65 million years. This doesn't really show up, does it? It's very weak laser. And I guess the battery is going dead. But
laser in the house?
I'll use my finger, I guess. But today is on the far right, and the temperature in the deep ocean is about 0 degrees Celsius. But 50 million years ago, it was 12 degrees, 13 degrees Celsius. The planet was so warm at that time that there were alligators in Alaska. There was no ice on the planet. No ice sheet on Greenland was covered by forests, and Antarctica had no ice on it. And but the planet, beginning 50 million years ago, cooled off until 34 million years ago. It was cool enough that ice began to form on Antarctica, and it glaciated quite rapidly. And then, since then, the planet has gotten still cooler. Now, we know the primary reason for that. The planet's temperature can be changed either by the amount of energy coming in changing, or from some changes within the atmosphere, or from some changes on the surface of the planet. But we know that our sun is a well-behaved main sequence star, which means it's still in the phase of burning hydrogen. It's nuclear fusion in the core of the sun is combining hydrogen to make helium and releasing energy. And the sun is slowly getting brighter over time. 65 million years ago, it was 0.4% dimmer than it is now. And because the Earth absorbs about 240 watts of energy from the sun, averaged over the surface, 0.4% means that the amount of energy absorbed by the planet has increased by 1 watt per meter squared, one of those tiny bulbs that Connor was holding up. But at the and also changes on the surface can also have an effect. The continents 65 million years ago were already close to their present locations, in terms of latitude. And so the change in the amount of sunlight absorbed due to where the continents are is less than 1 watt per meter squared. But the other thing, the atmosphere, we know that 50 million years ago, there was more than 1,000 ppm of CO2 in the atmosphere. During the ice ages, the coldest times, there was only 170 parts per million. Today, there's 389. That change from 170 to 1,000 is a forcing of more than 10 watts per meter squared. So the dominant reason for those large changes in climate is due to the atmospheric CO2. And that we know the main reason that happened. It's because the amount of CO2 in the atmosphere naturally, before humans started to burn fossil fuels, the amount of CO2 is determined by the balance between the source of CO2, which is volcanoes, and the sink for atmospheric CO2, which is the weathering process. As the rivers carry sediments to the ocean, the chemical reactions associated with that weathering end up depositing carbonates on the ocean floor and drawing CO2 out of the atmosphere. But those two processes, the source and the sink, are not necessarily in balance at any given time. It depends upon how many volcanoes you're getting, and that depends upon continental drift. Volcanoes occur where continents move and subduct beneath them ocean floor. And as this high pressure and temperature of the continents riding over the ocean floor causes the metamorphosis of the ocean floor, the carbonates into other rocks, and it releases CO2 that comes out in the volcanoes. And when India, and the one thing that was different 65 million years ago is India was still south of the equator. India was moving north at a rapid rate of about 20 centimeters every year, which is, for continental drift, is quite fast. And it was moving through an ocean that had long been the depot center for the major rivers of the world. So that ocean floor was carbonate rich. And as India rode over that ocean floor, the CO2 was released to the atmosphere, and the planet got warmer and warmer until India crashed into Asia and began to push up the Himalaya mountains and the Tibetan plateau. And then that reduced the source of CO2, the volcanoes, and it increased the sink because the weathering of these rocks in the Himalayas draws CO2 out of the atmosphere. So CO2 decreased and the planet cooled off over that time period. And those are huge climate changes. As I said, there were alligators in Alaska in that red part of the curve. But,
I think your clicker works now.
okay.
Try it. There you go, let's try it.
Yeah, great. New battery. The imbalance, the rate at which volcanoes put CO2 into the atmosphere is only of the order of 1/10,000th of a part per million of CO2 per year. And over a million years, that's 100 ppm of CO2, which is a huge change, and that can cause large climate changes. But look at the rate at which humans are changing CO2. We're increasing it 2 ppm per year. So we're changing things 10,000 times more faster than the natural process can change it. So humans are now in charge of future climate change. It would, of course, the administrator was right. You can have large changes, but those are on much longer timescales. And humans have, entire civilization developed during this current interglacial period called the Holocene, which has had relatively stable climate for the last 12,000 years. And now the future climate is going to be determined by humans, not by natural changes. And the other thing is that how much CO2 was there at the time that Antarctica began to freeze over? We estimate from this study that it was about 450 parts per million. Some other different studies have got somewhat higher numbers, but the basic point is that if we burn all the fossil fuels, we'll increase CO2 to much more than that. We would be heading the planet back toward the ice-free state. We can't say exactly how long it would take to get there, how long it would take for the ice sheets to melt, but there's no doubt that we would be producing a different planet, very different than the one that civilization has developed on. And another thing that we can do, besides looking at the Earth's history, is to look at what's happening right now. In the last few decades, since satellites began to make measurements. And one thing that we see is in the Arctic, the sea ice is melting. The amount of sea ice at the end of the summer fluctuates from year to year, depending upon the weather that summer. But you can see how much it is decreasing over time. It's now decreased by 30% from what it was a few decades ago. And now the Northwest Passage has been open a couple of times in the last few years because that ice is melting. And in fact, we're going to lose all of that ice at the end of the summer within the next few decades unless we slow down the emission of CO2. Another effect that we see is the increased melting on Greenland. The red part, the red area shows how much melting there was in 1992, and this is in 2007. And that fluctuates from year to year depending on the summer weather, but that area is increasing. And that melt area, the meltwater goes to a low spot on the ice sheet, burrows a hole in the ice sheet, and goes all the way to the base of the ice sheet. And there it increases the discharge of these giant icebergs to the ocean. Still, until we had some recent measurements. We couldn't say for sure what the effect was on the mass of the Greenland ice sheet, because global warming causes the atmosphere to hold more water vapor, and therefore the snowfall in the winter increases. That increases the mass of the ice sheet. Common sense would suggest that as the planet gets warmer, the ice sheets are probably going to get smaller. And now we have a quantitative measure of that, because we have what's a gravity satellite, which measures the gravitational field of the Earth with such a high precision that you can see changes in the mass of the ice sheets. And what we see is that Greenland is now losing mass, and at more than 200 cubic kilometers per year. And Antarctica is losing mass at more than 100 cubic kilometers per year. And what worries glaciologists especially, if you go back 10 years, these ice sheets were in mass balance. They were not losing mass. But now you can see that even the rate at which it's losing mass is now increasing in the last few years as compared to 6 or 8 years ago. And what we're afraid of is we're really going to fall off a cliff and these ice sheets will disintegrate rapidly. Another effect of global warming is on the circulation, the atmospheric circulation, the rising motion in the tropics, and then the subsidence in the subtropics, which causes the subtropics to be dry. That circulation cell is expected to expand as the planet becomes warmer. And what we observe empirically is that averaged over all longitudes, it has expanded by about 4 degrees of latitude. And that is beginning to have a noticeable effect in the southern United States, in the Mediterranean region, in Australia. And it's one of the reasons that Lake Mead and Lake Powell are now only half full. It's also one of the reasons that we see an increase in forest fires. And these forest fires now burn larger areas and burn hotter. And so it's more difficult. They even will burn not only the trees, but the seeds. It's so hot. And when that happens, then it's hard for the forest to regenerate itself naturally. And we see this in the Mediterranean region, in Greece, in Australia. They've had terrible forest fires, which they'd never seen before. Another effect is all around the planet, the mountain glaciers are melting back. In the Rocky Mountains, the Andes, the Alps, the Himalayas. And these glaciers have practical importance. In the dry season, the biggest rivers in the world, like the Ganges and the Brahmaputra, more than half the water in the river is from melting ice. So once these glaciers are gone, the seasonal cycle of the river's water content will be much more exaggerated. There will be heavier floods in the spring as the snows melt, and then it will be much drier in the dry season, which will have an effect on billions of people who depend on these rivers for fresh water. Another effect is on coral reefs. Coral reefs are the rainforest of the ocean. They are between a quarter and a third of the species in the ocean are associated with coral reefs. And coral reefs are under stress for several different reasons, but two of those reasons are associated with this increasing CO2. The warming ocean water causes the corals to bleach and expel their symbiotic algae, in effect die. And the increasing CO2 in the ocean water makes the ocean more acidic. And as it becomes more acid, the animals that have carbonate skeletons or carbonate shells suffer. And in fact, if it gets too acid, the carbonate dissolves and they cannot live. So for these sort of reasons, we can evaluate what is the level of CO2 that we should be aiming for if we want life on the planet to continue similar to what it has for many thousands of years. We conclude it turns out in all of these cases that the long-term amount of CO2 should not be higher than 350 parts per million at the most. And the most quantitative way to look at that is actually from the planet's energy balance. We mentioned, and Alec mentioned also, that the planet, because of these gases, is out of balance. There's more energy coming in than going out. And we can measure that, because where does this energy go? The atmosphere's heat capacity is limited, but the ocean has tremendous heat capacities. Most of the energy, some of it is going into melting ice, but more than 80% has to be going into the ocean. So if we measure the heat content of the ocean, and beginning in 2003, we began to have several thousand floats around the ocean which send instruments down to 2-kilometer depth, and we can measure the heat content more and more accurately. And we observed that the planet is out of energy balance by at least half a watt per meter squared. To restore the balance, if the imbalance is half a watt, you would have to reduce CO2 by 35 to 40 parts per million, and that means back to about 350 ppm. Now, the imbalance, I think, may actually be closer to 3/4 of a watt. That would mean 330 parts per million. But we need more accurate measurements. So if we want to preserve creation, the planet that civilization developed on, we need to reduce CO2. And what that means is that we cannot burn all the fossil fuels. We have only burned and put into the atmosphere the purple parts of this oil, gas, and coal. The total amount that still exists in the ground is uncertain. So there are some estimates that say we've burned half the oil already. Others say that there's more to be discovered. But it's very clear we cannot burn all the coal. Even though there's uncertainty as to how much there is here, we know there's a lot, and there's enough to cause us to go to the ice-free planet. So the one thing that, and there's a lot of CO2 in these dirty, unconventional fossil fuels, tar sand and tar shale. But if we would leave those in the ground, and if we would phase out the coal over the next 20 years, then CO2 would peak at something between 400 and 425 parts per million, and we could get it back below 350 parts per million. If we just let it go naturally, it would take a long time. It would take a couple of centuries at least. But if we reforest and try to store more carbon in the soils, then we could get back this century below 350 parts per million. But the essential requirement is we would have to phase out coal rapidly and not develop these unconventional fossil fuels. But what is really happening? Our government just signed an agreement with Canada for a pipeline to carry tar sands oil from Alberta to Texas. And we're building more coal-fired power plants. Those have a lifetime of 50 or 60 or 70 years. It doesn't make sense to be building new coal plants. We've got to phase out that. The governments talk like they understand the problem. The president says we have a planet in peril. And the politicians, there's a huge gap between their rhetoric and their actions. Basically, it's a case of greenwash. They say things that the public wants to hear, but their actions are not consistent with that. And if you want some quantitative evidence for that, we had the Kyoto Protocol go into effect about a decade ago. Up until that time, CO2 emissions had been increasing 1.5% per year. Since then, even with the economic downturn of the last 2 years, the increase has been 2.5% per year. So we're not only not decreasing the emissions, we're still increasing them. The fundamental problem is this: as long as fossil fuels are the cheapest energy, we will keep burning them. No matter what words politicians say, we will just keep burning them. And the reason that they're cheapest is partly because we subsidize them, but mainly because we don't make them pay for the damages to society. The human health effect of the air pollution and water pollution from fossil fuels is enormous. There are more than 1 million people per year around the world die from air and water pollution effects. And many, many times more have health problems due to pollution, but those health bills are borne entirely by the public. Fossil fuel companies don't pay you if you get sick from pollution. And they don't have to pay for the damage that they do to the environment, or they don't have to pay for the damage they do to the future of young people. So I argue that what we need to do is put a fee on fossil fuels, which can start out modest, but it should increase over time. And the public and businesses should know that this fee is going to continue to rise. And that fee, the money that's collected, should be distributed 100% to the public on a per capita basis. So the people who use less than average carbon, their emissions are less than average, they will get more in their monthly green check than they will pay in increased energy prices. For example, by the time the fee gets up to $1 a gallon on gasoline, that would generate $600 billion per year in the United States. If you divide that among the legal residents with 1 share for each adult and half a share for children, up to 2 per family, that would be between $2,000 and $3,000 per adult, and about between $6,000 and $9,000 per family with 2 or more children. And that's a simple, honest system where you know exactly where every dollar is going. It's very easy to see how much is collected from the fossil fuel companies. It's just long division to see how much each person gets. You don't want these systems that, and this sort of thing would stimulate the economy. It would put a lot of money in the public's hands, and those people who use the money wisely would be able to get more in the green check than they spend on increased energy prices. And this, by the way, is the only internationally viable approach, because India and China are not going to accept a cap. But already, China has agreed that it should have a carbon tax. Now I want to say a few words about the intergenerational injustice of what we're doing at the present. And this is a more recent photo of my daughter's 2 children who I showed earlier. And now my son has 2 children. This was taken when Emma was just 2.5 days old. Her brother, Jake, is a gentle giant. He's in the 1% category for his height, for his age, and he thinks that he can protect his baby sister. But unfortunately, what Jake doesn't know is that what situation he's going to inherit, what he's inheriting, is actually determined by what we do now and in the next, really in the next several years. We could very well leave a situation which is out of control of young people when they're by the time they're adults, and that's really inconsistent with the way our culture, with the way our country has ever thought about these intergenerational things. Or any parents, as you know, have always been willing to sacrifice for their children. And that's true in almost all cultures, that they do feel an obligation to the future generations. And let me end with, though, a couple of notes of optimism. The one is that although our country is not yet taking this seriously, China, which is now the biggest emitter, but by the way, what causes the climate change is not your emissions today, but the total emissions. If integrated over time, the United States is responsible for about 27.5% of the excess CO2. China is responsible for 9.5%, even though they have 3 times more people. So on a per capita basis, we're 10 times more responsible, and yet China is beginning to act responsibly. They they have invested enormous amount of money in solar. They're now #1 in production of solar energy, wind energy, and they're building 24 nuclear power plants. And what they have just said in recent days is that they're going to have a carbon tax, which will rise over time. And that's a very sensible thing to do because they want to encourage these clean energies to take over. Their atmosphere is very polluted. They have more than 300 million people who live near sea level. They don't want the oceans to be rising. So they're taking steps which are, I hope, going to encourage other nations to act in a similar way. And the other thing is what I came here to Oregon to talk with the legal scholars about, and that is the potential of the legal approach. The way and they call it the atmospheric trust litigation, but the way I look at it and started thinking about it some time ago was the fact that if you look at our nation's history, the Declaration of Independence starts right out by saying it's self-evident. We hold this truth to be self-evident that all people are created equal. They might have said men at that time, but they meant people. And now we've decided that they really meant people. That's the great thing about our Constitution. You reinterpret it as you go along. And the Constitution has in it the concept of equal protection of the laws. That is the basis on which minorities finally gained their equal rights. I mean, that was a major contributor. It did depend upon people in the streets also, but the courts could tell the government, give us your plan for desegregating. And they could require the government to report back as to how well they're achieving that. And I think that's something like that needs to happen, because what has become clear as I've gone to other countries, I thought that maybe it was just a problem we had here, but in fact, the countries that talk the greenest line are in the same boat. Their executive and legislative branches are under the influence of money, just like Washington is. The lobbyists have much more power than the average citizen. It's not a question of one person, one vote, and equal influence. Money talks in Washington and other capitals, and it's clear if you just look at the attempts at legislation in the Congress in the last year or so. Basically, the bills were written by lobbyists, and they were very ineffectual. So I think the courts are less subject to that kind of influence. And so that's why I think that's one approach we need to take. But we shouldn't give up on the democratic process. We do still have a democracy, and we can try to influence Washington. And that's why we're trying to organize this million-letter march. And I hope that you will look at that website and consider writing a letter, because the form letters don't have any effect on government officials, but personal letters, if there are enough of them on a topic, can begin to have some influence. Thanks. Okay. Thank you. So she says now we can have some questions and answers, if you like. discussion.
Well, I want to thank, this works, okay. I want to thank Dr. Hansen so much for this clarifying talk, and we do have some time for questions. I've been asked to moderate the questions, but I want to let you know about a wonderful practical house rule that the Moore Center has for events like this, and that is we welcome as many questions as possible. We want to get through as many as possible to allow as many people the opportunity. And so to that end, we invite only short, to-the-point, directed questions, and we do not invite monologues or position statements that are characterized as questions. Okay, first question.
Maybe, could I make one comment first? I forgot to say.
Oh, yeah, go ahead.
I usually, when I start on my talk, I make clear that I'm speaking as a private citizen.
Oh, yes.
And I'm not, in coming here, it's on my own resources. I'm not using any government equipment or anything. I'm just speaking as a private citizen. Okay.
Good clarification. I had yes, purple shirt.
How can we ever have a sustainable society when we have an economic system that depends on growth?
And then if you could kindly, I can repeat the question. Do you want me to repeat the questions, or do you?
Well, yeah, you can.
Okay, how can we have a stable economic society if we have, I'm sorry, how can we ever have a stable society if we have an economy that depends on growth?
There are so many facets to this problem. I just can't get into them in the talk, which I made longer than I probably should have anyhow. And that is one of the issues: overconsumption, or wasteful consumption, and even population. You know, there is a limit as to how much our planet can support without pushing the other species on the planet off and destroying the fabric of life on the planet. But I think you can be optimistic. You know, for example, the population, the fertility rate in most developed nations is now at or below the replacement level. The population is still going up. Mainly the reason the population is still going up fairly rapidly is that life expectancy is increasing. But as women become educated, having many children is becoming unpopular with most women. So I think there are hopes, and if we would take the steps to encourage that and make sure that women in all countries are educated and free to make choices, I think that the population can be stabilized and even decline somewhat. But we do need to, and the way that will happen naturally is if we do put a rising carbon price. It's going to make, you know, right now we subsidize importing of food from halfway around the world. There's no tax on aviation fuel. It was decided in the 1940s that governments wanted to encourage aviation, so they would have no tax on fuel for aviation. Well, that's still true, you know. And it's crazy. But if you have a price on carbon, which is rising over time, then we won't be importing our food from New Zealand. It will encourage nearby farms. And we have to push things in that direction. However, maybe that's all I should say on that one.
Okay, question right there.
Can you explain how it is that people are able to claim that there are all these scientists who don't believe global warming is real, the climate denier types? How do they manage that?
So the question is, how do you, excuse me, I'm sorry. The question is, how do you explain the fact that we still have climate deniers?
Yeah. Well, of course, the fact is that if you ask any authoritative scientific body, whether it's the United States National Academy of Sciences or the American Geophysical Union or American Meteorological Society or Royal Society in Great Britain, they all have very strong, clear statements about the reality of human-made climate change and about the threats that poses. But the 2 or 3% of people who dispute that are given enormous platform, in part because, a large part because of the moneyed interests who finance this, and the fact that our media is just not very good at really being objective. So what they do, they insist on having, whenever there's a person talking about climate change and human-made effects on it, they always have a contrarian at the same time, as if their status was comparable. There's no way that these guys could stand up before a serious scientific group. So, for example, when we do have studies, like President Bush asked the National Academy to have a study, well, that study group had put on it a couple of contrarian-type people, but those, they couldn't, there's a report that came out, didn't express any of their, because they simply couldn't stand up against the scientists when they're in a room with real scientists. But fooling it, it's easy. And you know, of course, the people who want business as usual to continue are careful to pick the really articulate contrarians, and they do a good job of confusing the public.
All right, I'll take a question from the black shirt woman right there. Yeah.
Could you just speak briefly about reduction of particles as we get more clean, how that could be affecting the greenhouse?
Yeah, as you...
I'll repeat the question. I'm sorry, because there's an overflow
Right.
room. So the question is, what effect will the reduction of particles have in terms of climate response?
Yeah, as I showed when Sophie and Connor were looking at these little light bulbs, the greenhouse gases are a forcing of about 3 watts per meter squared, but the net forcing changing our climate is only about half that, because these small particles, the aerosols in the atmosphere, are reflecting sunlight, and those are the visible part of air pollution. So as we decrease those, it will cause the warming to get larger. Now, there are some, it's a little more complicated than that, because these particles have not only white ones that reflect sunlight, but also some black, dark ones called black soot. And if we emphasize getting rid of all the black soot, then that will help, because the black soot causes warming, while the white ones cause cooling. And the truth is that we're never going to get the white ones to go to zero. We can decrease them quite a bit by reducing, when we phase out coal, because a lot of it is from sulfur in coal. So that's a problem. It's going to make the problem a little more difficult. And we can counteract that in part by reducing methane as well as and chlorofluorocarbons as well as CO2. But it does make the problem a little bit harder.
Matt. So the question pertains to the rate of change. Basically, can we expect change over a much shorter time span than, say, the end of this century? Yeah, well, that is the extremely difficult part of the problem, because it's especially these tipping point phenomena. These are all nonlinear phenomena, and it's like you can and make an analogy with the stock market or with the country's economy. If you have a practice like overspending, spending much more money than you're making, then eventually it's going to cause a problem. Suddenly, the day of reckoning is going to come, and you get suddenly a collapse. But it's hard to predict exactly when that's going to occur. Likewise with an ice sheet. We know
from the Earth's history that when ice sheets do begin to disintegrate, you can get very rapid disintegrate and sea level rise of 5 or 10 meters in of the order of a century. But that is hard to say. So I think, and that's why scientists have become worried, because on the ice sheets we see that they're responding faster than people had thought. And the sea ice in the Arctic is decreasing faster than the models had predicted. And we see methane beginning to bubble out of the tundra as it's melting. So, yeah, but the global temperature has been going up at about the rate that we expect given the energy imbalance of the planet. So, yeah, that's a danger. But that's why we need to bring the planet back to energy balance. And we technically we can do it, but it requires a rapid phase out of fossil fuels.
A question very far in the back, green shirt, you're looking behind, yeah. Oh, it's Lisa.
A little off the wall, perhaps, but I've seen photographs at night of the Earth from space, and there's all this light shining from all these cities. Decades ago, it was not so. And I know that when a light bulb puts out light, most of it's actually heat. Is there an impact that's measurable that enters into this discussion from all the light that's going on at night?
So the question is there a measurable impact from the tremendous amount of light put out by cities at night across the world?
Averaged over the planet, it is negligible. The biggest effect is the heat, as you mentioned, is actually the heat that's generated not only by lights, but by everything else that we do. And locally, that actually can change the local climate. So there is a urban warming associated with just the activity within a city, the energy and the heat that comes out from our activities. But when you average that over the planet, it's a couple of orders of magnitude too small compared with the effect of greenhouse gases.
I want to ask if any kids have any questions at the moment. I'll come back to you if you don't. Okay, we'll come back to that. Question back there, white T-shirt. Okay, well, let me try to repeat that question. The question is for Dr. Hansen. President Obama has lifted the ban on offshore oil drilling, the moratorium. But the broader question, that was a statement, but then the broader question is, why do you place faith in the judicial branch when, as you point out, the High Court, the Supreme Court, voted to allow corporate contributions to political campaigns? So why do you have faith in the judicial branch?
Yeah, well, of course, the first part, the comment about the president, did not increase your confidence in the executive branch, I don't think. But, and of course, we are very disappointed that President Obama did not take advantage of the goodwill that he had at the beginning of his term, or take advantage of the obvious implications of the oil spill in the Gulf to point out to the public the importance of phasing out our addiction to fossil fuels. But with regard to the second part of your comment, remember that this Supreme Court did vote by 5-4 that CO2 was a pollutant, and EPA should be able to regulate that. I think that the case that we can make, the scientific and intellectual case, the evidence that we can present, the consequences for young people of continued fossil fuel emissions is so ironclad that I think that what you see happening in the legislative and executive branches, where they give equal weight to the opinion of anybody who's willing to say what certain industries like to hear, that I don't think that will be true in the courts. I think so. I think although none of the branches are perfect, but I think the judicial branch has the best chance and is the least influenced by money. So we will see.
We'll take Dan Galvin.
I strongly support your call for carbon tax or carbon fee. But as you see in the case of China, also, for example, Germany, France, Netherlands, massive investments in carbon-free or low-carbon technology have been driven not merely by individual decisions, but by government policy subsidies. Would you support taking a portion of your green check and directing it to support prices for renewable energy, infrastructure, and technology?
So the question is, in a situation where you would charge a tax and then take part of that money for purposes, you advocated taking the money and giving a dividend check to citizens, but would you also advocate or consider taking that instead and putting it into green infrastructure?
The simple answer, and I'll give you a more complete one, but the simple answer is no. And the reason is that I do not want the government deciding on what the energy sources are going to be. Let the market make that decision. The government has proven it's completely incompetent in making the decisions. They would use the money to support clean coal, for example. They've already proven that. There's no, and there is no such thing. And but although allow that as a possibility, if somebody can develop economically competitive use of coal, which emits no CO2 or other pollutants, fine, that's on the table. But it's got to compete on a level playing field with the alternatives, including energy efficiency. And however, to make it, you have to give 100% of the money to the public, not to the government. The public will never, once you say the government's going to decide how to spend their money, the public's going to be against this. It's got to be very simple and honest, but you could give part of it back to the public in the form of coupons, which they can be invested in whatever technology. Because you would like to encourage the people to use that money in improving their energy efficiency and their reducing their carbon footprint, rather than going out and buying a six-pack or something. But those people who do waste the money are going to soon be at a disadvantage. They'll be paying more in their increased energy prices than they'll be getting in their green check.
This question over back there, man with the beard.
Dr. Hansen, I have read your book, Storms of My Grandchildren. I think it is an excellent book. I have great respect for your work as a scientist. But I am also greatly concerned about the manner in which you have treated, in your book, those who raise concerns about nuclear power. It reminds me of how the carbon naysayers are treating you. And my question to you is quite simple. Have you read Amory Lovin's publication, commentary on Stuart Brand's Whole Earth Discipline and on similar writings. And if not, I have a copy for you. And have you read Chernobyl, Consequences of the Catastrophe for People in the Environment, that was just published by the New York Academy of Sciences this year, showing that up to 1 million people have been killed by the accident of Chernobyl, and the results of that accident are still ongoing. And I also have a copy of that for you if you have not read it.
So let me rephrase the question for, especially for people in our overflow room. The question has to do broadly with the propriety of phasing out coal by going to another fuel that is just as deadly for future generations in the perception of the questioner, jumping from the fire to the frying pan. Is that?
And the other authors.
Well, and the questioner has sources, books, new books by Omri Levins and another one.
Yeah, I have read the first one, and I know all about Chernobyl and the nature of this Soviet power plant, which would never be allowed in any other country and would not be allowed in Russia now. But yeah, I know Amory very well, and he's the most popular guy in the planet because he says everything that you want to hear. He tells you you do not need coal, you do not need oil, you do not need gas, you do not need large hydro power, and you do not need nuclear. And he says we can phase over to all soft energy, which means like wind and sun. And he started saying that in the early 1970s, and he made a graph of how these soft energies would take over and how the others would decline to zero. And Amory says it is absolutely correct about the first thing that he emphasizes, which is energy efficiency. We can get a lot by using our energy more efficiently. And he compared his projections with government projections. And the governments always said we need more and more energy every year. And he was right. The government was wrong. What has happened, however, is not that the energy use has gone down the way Amory hoped it would, but rather it's been practically flat in the United States. And if you look at the renewable energies, you can see them on the graph because of hydropower. The contribution of the soft technologies that Amory advocates is invisible, and it is still invisible 3 decades later. And every utility CEO, and they're not just out to make money, they say they have to have baseload electric power. They can't just have some intermittent renewables. And the fact is, let's talk about nuclear. We had an accident in the United States, 3 Mile Island, which exposed Pennsylvania residents to radioactive gases. And the National Academy of Sciences has done a thorough study of that, and it says it's possible that 1 or 2 people in that population will die of cancer earlier than they would have otherwise. In the same population, 40,000 people will die of cancer from other causes. That was with second-generation nuclear power plants. What we're capable of doing now with the best technology is having more fail-safe operation of nuclear power plants. But the most important thing is that the biggest disadvantages of nuclear power can be dealt with technologically. Right now, what we're using is light water reactors, which burn less than 1% of the energy in the nuclear fuel. The other 99+% is left in a waste pile, which has a a lifetime of more than 100,000 years. So it's a tremendous mess that's being left. The fourth generation nuclear power plants can burn that waste and leave a waste which is less than 1% instead of more than 99%, and with a half-life that's measured in decades, not tens of thousands of years. And that because that technology can get almost all of the energy, there is enough energy to last more than 1 billion years. We have enough energy in the United States. We have enough material in the United States in the excess weapons-grade plutonium and in the nuclear waste from power plants to last more than 1,000 years. We don't need to mine uranium in the next 1,000 years. So it's a question, and the amazing thing is that there are more than 1 million people a year dying of air and water pollution, mostly from fossil fuels. Coal has got mercury, arsenic, the sludge ponds that are left behind, the pollution of the local water, it dwarfs anything that has ever happened from nuclear power. And yet people are not afraid of that. It boggles the mind. And the thing is, the thing that has caused physicists to have qualms about nuclear power is, physicists feel responsible for releasing the nuclear genie from the bottle. Well, it's too late. The genie is out of the bottle. So the question is, how can you deal with this in a most responsible manner? And what the United States is doing is incredibly stupid. What we're doing is sticking our heads in the sand. We should be the technological leaders. We should make sure that nuclear is as safe as possible. And it's not going to the idea was, well, if we can prevent any more nuclear power plants from being built, it'll disappear from the planet. That's ridiculous. There are 6 other nations that have fourth generation research programs, and they're expanding their nuclear power use. So the trick is to have that technology be as safe as possible and to be in a position that we can exercise global leadership in assuring that the danger of proliferation of weapons, of material getting into the hands of people who would use it against population is minimized. Yeah, I know. Every time I give a talk, I get the same reaction because good people, and these are many of my friends. If you'd asked me 20 years ago, I would be against nuclear too. But now I see that we've got a choice. As far as baseload electric power is concerned in the near future, we basically have 2 choices: fossil fuels or nuclear power. And I think nuclear power can be made safe.
Tim?
Just following up on that, about 8 or 10 years ago, I read about pebble bed nuclear reactors, which seemed to promise a number of things that you can.
Yeah.
Nothing more. So that was doing some research. Do you know anything about that?
So the question is there a new type of nuclear technology called pebble beds?
Pebble bed
reactors.
Yeah, pebble bed reactors, the advantage was really minimizing the danger of ever having no meltdown. There are other ways to have fail-safe operation. And the pebble bed does make it more difficult to burn the waste in a fourth-generation nuclear power plant. So I'm really not very keen on that anymore. It sounded good a decade or so ago because it had certain advantages. But now I think the ridiculous aspect of this is that we had the best brains in the world in the United States in this nuclear technology. And when Argonne National Laboratory, which was the lead laboratory, told the president that they were ready to make a fourth-generation nuclear power plants, then the anti-nuclear people. And there are a few who are ready to jump up and give this story. So my grandson, Jake, who you saw, he's the one who I say is a gentle giant. But he was speaking already at age of like 1.5. And I described my friend Amory and Tom Cochran and another one or two people who are the standard guys who stand up immediately and start explaining. And it sounds like to the senator or whoever is listening, it's hama, 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 because they don't understand the details of nuclear technology. And Jake went around saying, he loved that word, hama, hama, hama. So the rest of the day he was going around saying hama, hama, hama. But unfortunately, what am I talking about?
You're talking about hama, hama, hama. But I'll follow up as my, I just started saying that a lot. Let me follow up with a question because I'm moderator and I get a lot of questions outside this process even. I'll just follow up since we're on the topic. You know, a lot of people may disagree with you on what you've said. There's a more fundamental, perhaps, risk, even than that has been expressed already, and that is, you know, if we're going the nuclear path, are we expecting government to be functional in a world where it will not be functional? I mean, California is almost bankrupt. State governments are going bankrupt. We may lose a lot of federal capacity, and if we're relying on this kind of lethal waste, even if it were minimal, do we really expect government to steward that waste for its lifetime, or is that unrealistic? And should we be putting really our resources into figuring out how to create base loads out of wind, solar, you know, and whatever else we can find, how to create that consistency in power allocation, and also just reduce, you know, more efficiency and conservation?
I think there's really a good article, which it would be nice. I mean, you want me to read something which I've already read. I think you should read it. It shows the probabilities of a fire. You know, you have to deal in terms of probabilities. And the nuclear power can be made safe enough that the danger of an accident is so minuscule that it's no greater than the danger of having a great fire which would consume more people than a nuclear accident would have. I mean, you're suggesting the advantage of developing a clean source of energy that doesn't produce CO2 is, in fact, that we can keep a sufficiently degree of wealth that our society can function. I mean, if you're giving up on having a government, I don't think that's.
Oh, I didn't say that.
I don't think that's. You know, I mean, things have actually, in some ways, improved. We don't have the kind of wars like World War II. Many things have improved over time, and I think that a source of clean energy that's inexpensive and is actually something that's advantageous for keeping the ability to have a good life and allow other species to continue to exist on the same planet.
Okay, so let's move off that topic for now. Children, do you have any questions? I wanted to give you a special opportunity. Any questions from the youth? Okay, Jillian?
What's your opinion of carbon capture and sequestration? I know a lot of people think it's a good idea. To me, it seems like a crutch that's going to keep us comfortable for a long time.
So what is your opinion of carbon sequestration?
The technology of capturing carbon and then sequestering it might be useful for us getting back to less than 350, but I don't think that clean coal, that using it In fact, what it has, that whole idea has been used for is to allow continued coal use so that people will think, oh, they're really working on, they're in the process of doing something better. And as long as people see things improving, then they're willing to allow this nasty stuff and the mercury and everything, which is causing lots of problems, to continue to be emitted. Because they're working on clean coal and carbon capture and sequestration. But it will make coal so expensive that we won't use it. So in fact, the people who really know, utilities have no intention of doing that. But we might want to use it when we realize that we've got to get CO2 back below 350 parts per million. We might want to burn biofuels in a power plant, capture the CO2, and then store it someplace. And that way we draw down the amount of CO2 in the atmosphere.